Dear students, now the drug target mechanism when we learn, as I told you, it is being classified into enzyme category and receptor category. If enzymes are working like a drug target, there is a certain mechanism we have to learn, and receptors are working like a drug target, the mechanism is entirely different. Particularly, as I told you, enzymes, they are made up of amino acid combinations. Let us see one example that we have learned in surface chemistry. Imagine it is the site of an enzyme, and there a particular site on the surface of the enzyme. In surface chemistry we learned these are the active sites on the surface of the enzyme. There a substrate molecule will come. We learned the theory in surface chemistry. An enzyme will join with the substrate and to give an enzyme substrate intermediate. That will get converted into product and the enzyme will get regenerated. This is what we learned. The same strategy only here also. In our body there is an enzyme available. Well, let us take for example dihydroterovate. DHPS is the enzyme. So this enzyme is available in the bacteria's body and it is looking for PABA. What is PABA? Para-amino benzoic acid. I'll write the structure. So it has a benzene ring and it is being connected with the carboxylic acid group, COOH group. And one side it has a amino group too. So that amino group is in para position, so para-amino benzoic acid is the name of the compound. When this particular compound is available, amino acid is available, this enzyme will capture that so that the microorganism will start producing folic acid. It's a coenzyme. Folic acid is a coenzyme. So thereby it will start multiplying more in number. Now scientists have created a substrate which is looking similar to the shape of PABA. Imagine the PABA's shape is like this. Exactly, it is fitting shape. The same shape the scientists will produce another chemical that will act like a substrate. Before PABA goes and attack the enzyme site to produce folic acid, our sulfanilamide, that means I write the structure, it has same benzene ring and also an amino group available. Instead of carboxylic acid group, it has S, double bond O, and again NH2. This is sulfanilamide. This will resemble the structure of PABA. Before E goes and attack, E is called as a competitive inhibitor. They may ask in a 2 mark. Before that fellow goes and suits a place, E will go. When enzyme is targeted, this will go and completely block the position. Thereby, it won't allow the PABA to go and occupy. Thereby, without the availability of folic acid, the microorganism will get killed. Next one, they talk about allosteric. What is the meaning of this word allosteric inhibitors? Suppose I am giving a chemical, that chemical instead of going and attaching to the main site, active site of the enzyme, it will go and find a place in the sites of the enzyme. Not the original site, it will go for an allosteric site, extra site. Thereby, because of this attachment, the regular geometry or active site geometry will get crippled. That means it will get minimized. Thereby even normal PAPA comes to its place, it cannot go and get soot into that area. So thereby these chemicals which are supplied as drugs will do a wonderful job of covering the site, active site, or attacking from the bottom of the enzyme. Thereby it will not allow the substrate to go and get attached in the enzyme and multiply in the more number. So this is about enzymes as a drug target. We have to learn about how these receptors are acting like a drug target. It's a very specific area. For example, we take what are receptors. Let us understand the beginning. So you imagine it is a cell. In that cell, this is a cell wall. And imagine it is your home, and it is a compound wall. And in a compound wall, one of the portion is a gate, the main gate. Imagine like that. So I will elaborate that in the form of this is the cell membrane, and in the cell membrane you have to understand the cell wall has two portions, and one is this is the inner part of the cell wall, that is the outer part of the cell wall. This outer part, this is inner part. And there this is a gate. Actually in this place only the receptor is placed. This is called as a receptor. And the receptor is having an active site, the site where a molecule can go and give the required signal, maybe a positive signal or a negative signal. So what is it? Suppose there is a problem caused by a microbe, and that comes in the form of a signaling. Okay, it goes and attached to the site of the receptor. When it gets attached, what happens? This receptor will give signal to the inner part of the cell, maybe in the form of a sleepiness signal, or in the form of pain, or in the form of production of other amino acids or protein chains. That may happen. This is what is happening in a cell. So receptor job is to receive. Maybe in your house, the compound wall, the main gate is available. Imagine the receptor is like the calling bell. And if for a good purpose, if you click the switch of the calling bell and it is an indication that somebody has come outside, and you go out of the house and see who has come. In case in the neighborhood there are a lot of children available, they start playing with the calling bell of yours. That means they keep making a lot of noise, and it is a disturbance for you. So now the drugs will work in a two different manner. One is the drug will work like an agonist, and the drug may work like an antagonist. What is an agonist type of drug? What is an antagonist type of drug? Yeah, agonist type of drug will come and shoot exactly to the receptor position, and because of that the receptor will get switched on. That means pressing a calling bell, and so the required signal will be given inside the cell. Now the cell will understand, okay, I have got a positive signal, I have to synthesize something. That is a signal. That is called as agonist. What is the duty of an antagonist? Antagonist will go and attach to this particular receptor site and then switch off all the signals inside. That means it won't allow any of the signals to go inside. Now when we talk about receptors, the importance of adenosine we have to learn, being students. Yes, adenosine is a particular material which will go and get attach to the adenosine receptor in cells and give a signal, on signal to go for the sleeping. That is naturally happening every day. And imagine it's a situation where you are preparing for your board exam. There you have to be wakeful. You have to prepare longer time, maybe up to 11:30. Then what is the next step? You will ask your mother to give you a cup of coffee. She will prepare a hot cup of coffee and bring it to you. There, after taking it, you become wakeful. That means your sleepiness will go away from it. How come? Coffee is having a chemical called as caffeine. That will go and act like an antagonist. It will go to the cell membrane and go to the receptor site and get attached. Thereby, it will give a wrong signal for the cell. Don't go for the sleep. Be wakeful. So the natural process, by giving a chemical from outside, the signaling can be changed. That's how they talk about agonist and antagonist. For example, morphine. Morphine is an agonist type of drug. Some people who are having a severe pain, and that will go and attack the opioid receptors and make them to go for a pain relieving condition. Sometimes when we undergo a massive surgery, or people who are at the later part of their tumor life, that means cancer patient at their terminal stages, they have enormous pain in their body. During the time they will supply this opioid receptors, that is morphine. They will go and attack the site. And that morphine is not safe because we should not take it often. Morphine, cocaine, heroin and all, they are all drugs which are unsafe for the body because they will make a patient addictive. So that is why we should not take them more than what is prescribed by that.
Receptor interaction. The tissue constituent with which a drug is supposed to combine to produce a pharmacological effect is called a receptor. Receptors are important to the body's communication process. Most of them are embedded in cell membranes. The active site of a receptor extending out of the membrane receives chemicals known as chemical messengers, which pass messages between two neurons and between neurons and muscles. The active site of a receptor changes its shape slightly to accommodate a chemical messenger. Once the chemical messenger moves away from the receptor, the active site regains its original shape. Thus, the chemical messenger gives the message to the cell without entering it. There are a large number of receptors in our body. Each receptor shows selectivity for one chemical messenger over another. This is because the binding site of each receptor has a different shape, structure, and amino acid composition. Based on the interaction with receptors, drugs can be categorized into antagonists and agonists. Antagonists are drugs that bind to the active site of a receptor and inhibit its natural function. These are useful when a message is required to be blocked from reaching a cell. Agonists are drugs that behave like natural chemical messengers. They bind to receptors and activate them to produce the desired response. They are useful when there is a lack of natural chemical messengers.
So dear students, we learnt about the drugs and their classification, and then how they go, the mechanism of a particular drug into the body, and which place they go and attack. Everything we learned. Now, the next part we have to talk about the therapeutic action of a drug. Therapeutic, I mean to say about the treatment part of the drug. So different varieties of drugs are available in the form of medicine we take. And those medicines, what kind of treatment they make, what are the different kinds available, one by one we will be discussing in this session. In particular, the other day I gave you an example of our stomach intestine issues and also acid related problem. And some people during the exam hours they feel more anxious and stress filled and they take it very hard for their body. At that time, some of the students I have seen in the past, they have the complaint of ulcer or stomach pain and a lot of sweating. All these are the negative impacts of this exam fear. And during the time the doctor suggests to take enough rest and in break the required amount of food, not to go for oily or fried item, all those things are the common support. In case it is not okay, then the doctor will prescribe some medicines. And before taking medicine, we should understand, see what type of medicine the doctor is giving, why am I taking such medicine, how long I should take the medicine, all that we have to understand. Because when you are overstressed or you are in anxiety, histamine will go and initiate the receptors available in the walls of your intestine. They will go and give a signal to produce more amount of HCl in the body. So that will be an adverse effect. Your body is having a layer of mucus, so many layers are being available, and the HCl may not be able to go and corrode the walls of the intestine. That's how God has created. At times, because of your food habit and also the lifestyle modifications, more acids get secreted, then the mucous membrane will get disturbed. Again, it will go and corrode the walls of the intestine. You don't believe the acid available in our chemistry lab is diluted compared to the acid available inside your stomach. That you should understand the problem behind it. Acid is inside, so you have to take care of your health. So this time what happens, the histamine is giving a signal to go for more HCl production. So thereby we give a drug called as ranitidine. Instead of giving aluminum hydroxide or magnesium hydroxide, the direct bases which will neutralize the acid, we go and block the receptor which is activated by a histamine. So cimetidine or ranitidine is a drug given that will go and suppress the behavior. So the acid secretion will get reduced. So this is how we have to act. So such a way we classify them into different types. To start with the first type, we are going to talk about tranquilizers. What are tranquilizers? Tranquilizers are the drugs which are supplied to induce sleepiness in our body. Sometimes you would have seen in Hosur or Talawadi, or if you look at our Bannari region, the elephants sometimes they come inside the households or living areas of the people. And they try to kill people or they damage all the crops and all those damages they do. Elephants are huge animals and they can topple even bigger moving things or vehicles also. They can demolish the buildings in minutes. So from the forest department, the trained people will come they will tranquilize the elephant or they will inject medicine. That medicine will go and make the elephant calm, and then they will do the job of shifting it back into the forest. So for our body also, certain times we require the presence of the tranquilizers. So in tranquilizers, there are two classifications available. One is major and other one is minor. So in major tranquilizer, we talk about the drug which is supplied, haloperidol can be, and in minor they talk about the diazepam. These drugs will have a neurological effect on the body. They go when being supplied, they will suppress the neural activities, thereby the depression can be reduced, anxiety can be reduced, and the problem of wakefulness, sleeplessness can be reduced. So that is the job of tranquilizers. The next area we have to deal is analgesics. What are analgesics? You can say directly the analgesics are painkillers or pain relievers. Okay, we can talk about painkillers. These are also medicines we take. What are the jobs of painkiller? Imagine you are playing in a football ground without proper boot, and you go for one occasion, you go for a wrong kick, and unfortunately you get a ankle twist or maybe a sprain in your muscle, and you are suffering from a lot of pain emanating out of that area. You don't know how to manage that. You start shouting and you are seeking the help of the physical education teacher, and he comes and immediately applies some of the sprays, and that spray will go into the peripheral area of your skin and reaches the nerves around the peripheral nerves around the place and reduce the problem of the pain. So see how the allopathy medicines are acting. To the symptoms they go and act and avoid the symptoms being transferred to the CNS, to the brain, so you will not feel the pain. And thinking that the problem is being rectified because of spraying, and you start moving, and the mobile action of all these nerves and muscles will make that problem rectified by itself. So that is how an analgesic work. And how to classify analgesics? Analgesics are classified into non-narcotics and narcotics drugs. I told you the other time, narcotic drugs like morphine, codeine, all these drugs have a bigger impact in any of the recipient body. That means they will have an addictive effect. They are narcotic in nature. But non-narcotic, we can talk about so many things. The first one is anti-inflammatory drugs. What are anti-inflammatory drugs? These are the drugs which will go and suppress the inflammations. What are inflammations? Sometimes you get throat pain, and if you closely observe by passing the torch light, and there the redness in that area, so the throat becomes very sore and rough. All that is action created by the bacterial infection or microbial action. So that inflammation will cause uncomfort feel, or sometimes they will give you a lot of pain. In that time, if you go for anti-inflammatory drug, for example, the mostly used one is paracetamol, paracetamol. This is the drug, actual chemical name. I will give you the structure. And paracetamol is the normal drug which will cure many of the problems, but they have it in the form of different names. Like they go for Calpol, they go for Action 500, Dolo 650. And the main combination, if you look at the wrapper of the tablet, it will be paracetamol only. And that means the generic medicine, nowadays they are talking about the generic medicine, which is the actual chemical will solve the problem. But that medicine may be very cheaper in rate. But the pharma manufacturing companies, they may come out with a different combination, with a different problem solving ability, has a different names, and obviously their pricing may also be different. So paracetamol can be taken as an anti-inflammatory drug, and we can talk about antipyretic. See, antipyretic drug, the word pyro talks about heat. Sometimes your body develops a heat. You can say the times of fever. Why do we get fever? The normal body temperature, sometimes it is rising due to the intrusion of some unwanted microorganisms. So that time the temperature of the body increases. That is felt by the lower part of the brain, hypothalamus, and that will give a signal to the other hormones and other parts of the body to react. Sometimes it is not manageable. We take a tablet like aspirin. Aspirin is like acetyl salicylic acid is the name of the drug. So this aspirin will do the job of reducing the body temperature. You can see that after the intake of the tablet, the sweat glands will produce a lot of sweat, and your body will be fully with the water now, sweat water, and obviously to evaporate the water, the body has to lose its energy, heat energy, so automatically the body temperature will come down. So that is antipyretic drugs. Aspirin, heat reducing, fever reducing. And sometimes aspirin will do the job of broadening or widening the blood vessels, so that the blood can easily flow. That's why some of the patients who are having heart attack, they are supplied with aspirin tablet to safeguard their life. Then we can go for NSAID, non-steroidal anti-inflammatory drugs. So these NSAID drugs are also coming under like ibuprofen. They are coming under analgesic. They are painkillers. Sometimes when you are not okay with pain, normal headache or some of the bodily pains, at that time, rarely we are supplied with some of the medicines which are acting like analgesics. They are otherwise known as painkillers or pain relievers. The next type of drug classification with respect to the therapeutic action is nothing but anesthetics. What are anesthetics? See, these are a class of drugs which will make a patient unconscious. That means the patient will expect or he will experience a loss of sensation. Those drugs we call them as anesthetics. Anesthetics are further classified into two types. One is local anesthetic and the other one is general anesthetics. What are local anesthetics? They will act only in a particular area of a problem. For example, if you go to a tooth extraction, the doctor is suggesting you for the extraction of tooth, so he is suggesting you to go for a localized anesthesia. That means he will inject in your gums or spray in your gums and then do the job of removal of tooth. So those local anesthesia, peripherally the nerve action will be curtailed and the problem will be rectified only in a selected area, and that is of two types, ester linked and amide linked. So ester linked we can talk about procaine is the most used anesthesia, and amide linked we talk about lidocaine. So depending upon the requirement you can go for this. In case if you are going for a major surgery or a transplantation or a bypass surgery or knee replacement or fixing plate in a broken limb, bone part of the limb, during the time some 4 to 5 hours you have to be in unconscious state. During the time the doctor will do the required surgery. And this time they go for two types of anesthesia. One is intravenous. Propofol is usually given, intravenous type of injection. Otherwise they go for the inhalation, isoflurane can be given. That means they will supply a mask along with the oxygen supporter. The particular chemical will be supplied. That will go, and these chemicals will go and attack the CNS, central nervous system. Central nervous system in the spinal cord. And that is like your local telephone exchange. So the telephone exchange get signal call from one particular area, and all the connections they will be controlling, and the required connection will be given to the next area. Like that, it is central nervous system is the main controlling section. So that whole central nervous system will become inactive, unconscious, made inactive. So no nerval transmission to the brain will be done. So the patient will almost go to a inert state. So the surgical procedures without any disturbance the doctor can perform. So that is called as general anesthesia. Two types, intravenous and inhalation type. The next one I think we have elaborately discussed about antacids. So these are the drugs or chemicals which are supplied to the body to reduce the acidity of the stomach. Obviously we can go for bases, and bases usually aluminum hydroxide can be given, or milk of magnesium hydroxide can be given, or we can go for ranitidine or cimetidine. And you can see most of the drug combinations of doctor, they may say this particular drug you have to take before meal, before half an hour of your meal, and those drugs will go and rectify the problem of ulcer by controlling the acidity. As I told you, the receptors will be blocked by the particular drug, so that HCl production can be suppressed. So this is about antacids. The next type of drug with respect to therapeutic action is antihistamines. What are they? Sometimes the people will have the problem of allergy by taking some of the medicines or sometimes with the interaction with the outside world, they may get some allergic sensation. Some may have a problem for dust, some may have a problem for pollen grains or like that. Even ice creams or certain varieties of food. Those allergic sensation can be reduced by giving medicine called as cetirizine. Cetirizines, these medicines will act on the histamine 1 receptor and they will suppress the action of this allergic sensation. So they are coming under the category called as antihistamines. Our next area is fighting against microbes, that is antimicrobials. Yes, these are the warriors which are sent inside our body to kill the disease-causing microbes. The first one, hope you know, beta-lactams and the importance of penicillin. Alexander Fleming is the reason for the penicillin, and he saved the life of so many of the soldiers. And that is the activity of the penicillin, antimicrobial. What is the job of a beta-lactam? Beta-lactams will go inside the body and it will work on the cell wall of this microorganism. And the synthesis of cell wall will be curtailed, restricted. So because of that, they will lose their cell wall, they can be easily destroyed. And penicillin, so many varieties are there depending upon the requirement. You would have seen the doctor will check the patient's body and then he will try it out. And sometimes when we go with the dental issues, pain and infection in the ears, infection in the throat, and all these lung infection, all these problems, they'll go for treating them with the penicillin or beta-lactams. The next category in microbials is antimicrobial is macrolides. Erythromycin is the drug which is usually supplied. That will go and attack the ribosome and then it will try to stop the protein synthesis. So for that purpose they give this medicine. So the macrolides job is to resolve the problems of GIT, that is gastrointestinal tract infection mainly, and genital infections. So that is intestine oriented, all infections, they can go for this erythromycin kind of drug. And fluoroquinolones is the next area. Usually ciprofloxacins are given as medicines for that, and that will act in particular areas of the DNA gyrase. So it will stop the production of the enzymes for the growth of microorganisms. And usually urinary tract infections, main drug supplied is ciprofloxacins. So their UTI, that is urinary tract infection, sometimes the infection level increases, the bladder, urinary tract will get accumulated with more of infectious thing, then they have to try with this drug. And that's why during the summer days we have to take a lot of fluids, water-rich fluids and juices, because accumulation of more of infected urine in the bladder is not safe. The next one we have to talk about tetracyclines. Tetracyclines, the main drug usually we give is oxytetracycline type. That particularly act in the ribosome 30S. So this is the main ribosome responsible for the synthesis of protein. So in that place it is acting. So oxytetracycline can be used for that purpose. Then next one is aminoglycosides. Sometimes when we are wounded, its best thing is to protect the wounded area, the open wounded area with some antimicrobial ointments. Usually they suggest neosporin or neomycin, such drugs they will apply, the ointments they apply. The main job is to go and cover the area and avoid the attack of microbes, the open wound. Even if microorganisms are touching our body, it is not a big issue. But if they are attacking the open wound and their multiplicity and infecting the total bloodstream will happen. So to avoid that, we go for aminoglycosides. And the next category is we have to talk about antiseptic. Particularly povidone iodine or hydrogen peroxide is used antiseptic, and sometimes when you go to the hospital in the emergency, they go for such ointments or solutions. And this hydrogen peroxide, in the previous chapter we learned, that has the ability to release more amount of oxygen when it is spilled onto the body cell open wounds. So that will clean the area and remove all the microbes around the place. Some of the antiseptics we are using, like mild diluted dosage of Dettol or Savlon. They have an alcohol combination. They will kill the germs and microorganisms around the place. That's why they are called as antiseptic. Otherwise that area will become septic and the pus cells will try to go inside the body, and one occasion will come we have to amputate that particular limb which is fully infected. And the next one, it is disinfectant. Most of the disinfectant, it is happening nowadays, the season of virus spread, they supply a lot of disinfectant. We have to thank all these sanitary helpers. We are cleaning our environment, and now we can see the disinfectant like a chlorine and hydrogen peroxide are highly oxidizing in nature. They will go and break the walls of the microbes, then they will kill them. So in the form of soap also we can clean our hands often, so that we can be disinfected from the germs. So these are the areas microorganism enter into our body. By supplying such medicine, we can keep ourselves safe. Part in the therapeutic action of drugs, we have to talk about anti-fertility drug. So these are the drugs which will act against the fertility. So they will be classified further into synthetic estrogen and synthetic progesterone. And we can take example menstranol. This is the example for this. And here when we talk about norepinephrine is the drug which is given for a synthetic progesterone. What are they? And actually the normal hormones in our body will increase the activity of ovulation, fertilization in normal human being. But if you want to reduce them, suppress the activity of fertilization, we have to go for an external drug. They are synthetically prepared hormones prepared in the laboratory. And those hormones like menstranol and norepinephrine, all these hormones will have the tendency to suppress the fertilization process. So that's why they are always called as birth control pills. So these are the areas we talk more about the therapeutic action of different forms of drugs like tranquilizer, analgesic, anesthetic, antipyretic. We learned about antihistamine and antimicrobial drugs, finally anti-fertility drugs. So this is the first part of the lesson. We talk about drugs. The next session will be learning about food and their preservatives and different forms of colorants added in the food.